Yo, what's up? I'm eating some food while I started this video. That was a bad choice. Sorry, hard to talk with crackers in your mouth. Hey, today estimation of quotients with compatible numbers. There's a lot to unpack here. This one is not as straightforward as some of the multiplication things. We'll talk about that. I also just want to think about this concept of estimation and base 10 and so on and so forth. So instead of telling you, let's just start doing it. Um, Previous skills to this that are helpful is understanding that base 10 form of either multiplication or division, because remember, those two are related. They're related in what we call the inverse operation. So if you know how to multiply, you know how to divide. If you know how to divide, you know how to multiply. If you need to solve a division problem, you can use multiplication. And if you need to solve a multiplication problem, you can actually use division. So those are some of the things that we're going to talk about. The most recent background skill that's helpful in that is that we've been looking at things like, I don't know, like 400, actually, let's call it 4,800 divided by 60, right? And when thinking about that concept, I'm gonna write over the inverse operation with that. We were thinking about the steps of seeing this, like underline your non-zeros, right? So we can just actually treat this as 48 divided by 6. That would be 8. And then in this case, instead of just counting place values like we did in multiplication, we are doing the laundry, as I like to say. We're matching zeros. So the zeros from one number, zeros from another number match. This one does not have a zero, so I give it a match over the answer. And then we can actually even double check that by multiplication. So 8 times 6 is 48, and then 2 zeros. And that's what we started with there. So that was the previous skill. The concept today of estimation of quotients with compatible number is to actually do the same thing. We actually want to do the same type of math to where we're estimating, meaning rounding numbers, to get them to this base 10 so that we can just do some division. But again, with the compatible numbers. So break it apart. We're talking about estimation. So when we talk about estimation, that is meaning we are getting about, right? About how much. We don't want the exact answer. We're just getting an idea. And estimation is great because it can help you double check your answers. So once you've done some math or you estimate, then you do the math, and then you're like, oh yeah, my answers are pretty close to each other, so I must be doing the right thing. And then when we're doing that about, also we're thinking then about rounding. Now here's the part that gets tricky. Up until now, right? Maybe we did something like when we did this with multiplication, like 358 times 27. And if I had to estimate that, I would say, oh, well, this is about 30. And this is about compatible numbers. I don't know. I'm going to call it 400 because that's compatible for me. And I can say, oh, well, 4 times 3 is 12. And then 1, 2, 3, 1, 2, 3. So my answer is about 12,000. Like that worked really good with multiplication. In the division standpoint of things, this changes. So that's what we really want to look at. Like we need to understand this skill and use this as a foundation, but it is not as straightforward. So let's actually talk about that. So if we're estimating quotients, right? The answer to a division problem. Let's say we have something like 287 and we are going to divide that by 42, right? Yeah, I'm not going to know that off the top of my head. And I'm not even going to worry about the exact answer yet. First, I'm just going to estimate, right? So the first thing we want to do is get that estimation. So if we think about what we've done in the past, well, that just means I'm going to do some rounding. So let's see here. This is about 300 and this is about 40. Great. But look where I'm at. This gives me a weird predicament because what I'm thinking about is 3 divided by 4. And that doesn't actually really work for me, right? 3 divided by 4 is not going to work here. I'm not actually going to get a whole number out of that. And then that gets confusing. And remember, with estimation, I should just get some easy whole numbers. I should get something that works really well. So 3 divided by 4, that doesn't work. Okay. But then we talked about this yesterday, whenever you're watching this video, about, well, okay, if that didn't work, well, then maybe I'll just do this and I'll underline 30. and I'll say 30 divided by 4. Well, again, again, that doesn't work because I can't, right? I can't, here's my 4 parts. And if I put 30 in here, it's not going to happen equally. I can't distribute 30 equally into 4 and get whole numbers. I'll have some remainder I'll have left over. And so then that gets really confusing. So this is what I mean with division. When it comes to this estimation part, we actually can't just randomly round to numbers that seem really easy and compatible. We have to be very intentional. We actually have to think, what are we doing and why are we doing it? So let's do that. This is the real work in this. Oh, look, it did that thing. Look, there we go. All right, sorry. I went to delete one thing and then everything else deleted. Anyway, okay, so actually, I'm even going to go all the way back here. Forget this. Let's start all over. So one thing we know, right? One thing we know is that this concept of estimation and division actually can be rooted in the inverse. And this is very helpful because this is, again, thinking about multiplication or that concept of multiples. And yes, I'm going to go on a little side note and talk about this before we go solve this 287 divided by 42. And what I mean by that is, let's do, what should we do? Let's do 36 divided by, I feel like I always do this one. I was trying not to, but whatever. Let's do 36 divided by 6 equals something. Well, technically speaking, what this is saying to me is I'm wondering how many groups of 6 do I need to make 36? And we talked about this before with this idea that this actually can be by multiples. If I think about 6 and by multiples, again, that's just skip counting, right? Skip counting. If I think about skip counting, well, one group is 6, right? 2 groups is 12. So here I am skip counting. I'm doing my multiples of 6. 6 times 1 is 6. 6 times 2 is 12. 6 times 3 is 20. Or 6 times 3 is 18. 6 times 4 is 24. 6 times 5 is 30. 6 times 6 is 36. And yes, I know, you know this fact. You're probably screaming at the computer like, I already know that, but that's not the concept. It's understanding this. Because what this proves to me is I have 1, 2, 3, 4, 5, 6. I have 6 groups of 6 that get me to 36. So I'm actually using the multiples. I'm using the multiples to make sense of this problem to solve. And that is actually what we can do with this compatible numbers deal. Because remember, compatible means they work well together and multiples work well together. So now that I went crazy on that tangent, I'm going to actually just change the page. I got to remember this, 287 divided by 42. Okay, so if we think about that, right, this is saying that I'm actually working with putting 287 into 42 groups or groups of 42. You could look at it either way. And so I'm actually going to start by rounding, and this is actually step 1. I'm going to write this. We're actually going, first step we do is actually round the divisor or divisor, whatever you want to call that, right? So that's actually this number, the number we're dividing by. That's why it's important to know this vocabulary. And I'm going to round that first. And let's put this because it's important. I'm going to round it to a base 10, meaning, again, there's a 0 somewhere. And in this case, I'm just going to call this 40. Okay, so that's a really good, important step to be thinking about this because that's going to help me actually make sense on how to round. I'm going to have to do more work before I round. And so from there, I'm actually just going to do my multiples. Now, skip counting by 40 is the same thing as skip counting by 4. I'm just putting a 0 on the end, right? So I could say 40, 80, 120, 160, 200, 240, 280, 320, 360, 400, right? So there's my multiples of 40. Again, if you're like, what? I don't know that. Notice I was just skip counting by 4s, and then I was just putting a 0 on the end of each one because it's 10 times greater. Now, what's great about these multiples is they actually tell me what I can round my dividend to. Remember, the dividend's the thing we're dividing up, right? And our dividend is usually the largest number, not always, but in this case, especially in fifth grade math, and that is most cases, it's the number that I'm dividing, which is up here. So this is my dividend. And if I think about that, if I look at this list, I'm actually looking for a number that's compatible with 287. Like 287 rounds to what number? And here it is, 280. So I actually can then just say, oh, I'm going to round this to 280 because they're compatible. And then we can go back to doing the math that we did yesterday, which is underline my non-zeros. So 28 divided by 4 is 7. Match my zeros. There are no other zeros, so there's my answer. Right? So that's actually what we're dealing with right now is we're dealing with this idea of that in this case with estimation, we actually have to be a lot more intentional about how we find this. Now we'll practice this more. And I guess step 3 would be divide. And that gets my estimation, right? 287 divided by 42. Oh, let me rephrase that. Is about 7. Okay, so that's a lot of talk about one problem. Let's try this again to continue, and we'll do these 3 steps. I'll put them over here. So let's see. We're going to round the divisor or divisor to base 10. This will make more sense as we practice it. 2, I'm going to list the multiples. And then 3, we are just going to divide, and that will get our estimation. Okay, so our second problem here could be something like, let's change colors for this. Let's say 320 divided by 11. Okay, well, this one already, I'm already thinking more, and this is again where you just start to really play around. So there's 2 options to this one, which I kind of laugh already picking this as the second. If I round to a base 10, I guess the really first thing I can do is round to 10. And then I list my multiples of 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Okay. Gosh, this seems to be going on for a while. But that's okay because what am I trying to get to? Well, I guess I could keep going. 110, 120. I'm technically getting to 320, but I feel like I would be there a long time. So, oh, wait. I guess in this case, now that I've done this, my base 10 is already made. You see that? My base 10's already there. Because it's got that 0 in there, and that's always something I want to look for. And so actually, after doing all this work, even though those were some of the steps, this is that difference between memorizing math and then thinking and learning about math. Is like, sure, I can memorize and do these steps, but notice how these steps don't really work well for this problem because I already have base 10. This actually already says 320. I can stop right there because now I can just do the math. This is the math from yesterday. It's got base 10 in it. So again, I'm going to underline the non-zeros and divide. So 32 divided by 1 is 32. And then I'm going to match my zeros. They're a match. I have none left. So 320 divided by 11 is about 32. So that is 100% one way I could do this problem. Now, there is another way to do this one. And again, this is what I'm saying. It's like we want to approach, like, yes, we have some steps, but if we really understand base 10 and we really understand multiples and we really understand the math that we're doing, we can actually approach this in another way. And watch, I'm going to show you what I actually do here. I'm actually not going to round 11 this time. In fact, what I'm going to do is I am going to keep this 11 and I'm going to do those multiples. 11, 22, 33, 44, 55, 66, 77, 88, 99. I like multiples of 11. And I'll just stop there because the reason I'm actually stopping there is I didn't have to go much further because if you think about The non-zeros, if I think about this problem up here, the non-zeros, look at this. This is a 32. Well, if I look, this 33 is a great place to round it to, right? And then again, 33 divided by 11 is 3. This 0 does not have a match, so I'll give it a match. And actually, then I could also estimate this one as being about 30. Both of these really work. In fact, one might be a little more accurate than the other. I don't know. They're so close. I think both of these work really well. So that's one thing to also keep in mind is, yes, we have these really cool steps that help us make sense of it. But then once we really understand the steps, we realize there's so many other ways to do things. And so I'm actually going to just delete this page and keep those steps. And let's try another problem. And yes, I know it's a lot, but you got this. We got this. Well, let's just do one more. And then, you know, as always, ask questions with the work. So let's go with, let's just do a big one. Let's do a big one. Sorry, I don't know why I got so excited. Let's say something like 2,491 is being divided by 48, right? So again, sure, looks big. We are estimating, so we don't have to do the exact estimate. So let's, in this case, again, do our steps. So step 1, I'm actually going to round the divisor to base 10, and that's this number. So I'm going to round this to 50. And then I'm going to use that. Now, here's another way to think about it. I could, and watch, this is why I want to like really have you be thinking about multiples and division and base 10. This is why I'm always on everyone's case about learning and not just memorizing steps. I could sit here and list multiples of 50, but remember, I'm trying to get to 2,491. I feel like that's really far. So instead of getting to 2,491, right? Or a number that's close to that, I'm actually going to think here. I'm going to think base 10, and I'm actually going to focus on the 5 here. So I'm going to do multiples of 5, and I'm actually only going to focus on the first 2 digits here because I'll probably round these to zeros anyway, right? The 9 and the 1, since it's base 10, right? Because that's what I want. So if I think about that, it's 5, 10, 15, 20, 25, 30, 35. Oh, wait, 25. So instead of 2,491, if I round this to 2,500 and I divide it by 50, now I can do, again, our math. I'm going to underline the non-zeros and divide. So 25 divided by 5 is 5. And then I'm going to match those zeros. So this 0 matches this 0. This 0 doesn't have a match, so I give it to the quotient. And there's my answer. The answer is about 50. So again, I am doing these steps, but I'm also doing it thinking about base 10. And again, instead of listing out 50, 100, 150, 200, 250, 300, 350, 400, 450, 500, and getting all the way to 2,000, I actually can eliminate that by thinking base 10 and just thinking about the non-zeros. Wow. Okay, crazy. Let's do one more. I know. You're probably like, dude, you said that was the last one, but I feel like we haven't got an opportunity to just practice exactly what this is. So I'm going to go here and I'm going to go here. Now, again, remember my first step is I'm going to round the divisor. I'm going to round the divisor into a base 10. So that's 20. Now, again, remember, I could sit here and list out 20, 40, 60, 80, 100, but I got to get all the way here. So what I'm actually going to do is I'm going to focus on my non-zeros in this case. I'm going to think 2, 4, 6, 8. So I'm going to keep this as the 8, but then I'm going to round that and go 800. And now we have 8 divided by 2. That gets me 4. And then 0 matches a 0. This doesn't have a 0, so I give it. So my answer is about 40. And you could still check this, right? You could still totally check this using the inverse operation to see how you're doing. I could say 40 times 23 is 815. Again, it's an estimation. So maybe I'll just round this to 20. And 4 times 2 is 8, and then my 2 zeros is 800, and that looks pretty good, right? So this is the flexibility with it. Like, for real, this is truly what I'm asking you to be thinking about when it comes to compatible numbers in math. It's not just grabbing two numbers and doing something with it. It's really stopping and thinking, okay? I know this was a long video, but it really does have a lot to have us be thinking about. So make sure as soon as you finish this, ask questions, do the work, stay focused. Do not ever leave confused. This is not the simplest stuff in the world. So it's okay that you're like, this doesn't make much sense. Plus, it's also coming from me and I'm babbling. But I trust you. You're great. Keep up the good work. And we will see you next time.